At the Edinburgh Royal Observatory, Jim Dunlop and Ross McClure are trying to see the cosmic dawn by tunnelling deep into space.
What we're trying to achieve is see the beginning of things, see when the first structures in the universe formed, first stars, first galaxies.
And to do that, they have been using the Hubble Space Telescope to take one of the most important pictures ever. This faint blob turned out to be an entire galaxy.
See, it's not a star, it's not point-like. You can see it's slightly extended, which proves it's a galaxy, maybe about 20 times smaller than our Milky Way. But that's about all we have in this galaxy. We can't even measure its colour very well. It's only just detected by Hubble in its very reddest wavelength.
There's a certain excitement to being the first person to ever look at that image, and from that image see this object that nobody's ever seen before.
And until the next generation of telescopes come online, it's as far away as we can possibly see. And in 2013, SkyMapper presented Stefan with one particular star that looked quite unlike any other.
Here you see about 100 or so ordinary stars scattered around the field. And in the centre is the star that we discovered.
The initial reading from SkyMapper suggested that this star had an incredibly low iron content.
At first we thought we must have done something wrong here, but we confirmed it the next night, and that's when things really got exciting.
The next step was to take a much closer look with a much bigger telescope.
We were lucky enough to find some telescope time over in Chile, and we stared at this one star the entire night, building up a very detailed spectrum of the star. There are a number of things that we saw that we just hadn't ever seen before.
With enough light, it's possible to make a detailed spectrum that can reveal the precise ingredients of a star. 2,000 antennas spread over more than a square kilometre, all tuned in to the radio signal from the cosmic dawn.
So what we've got here are the antennas. We have a cluster of 16 of them here. So you can build a lot of antennas and get a very sensitive telescope.
Sensitive enough to receive radio waves from the primordial fog that have been travelling more than 13 billion light years. And handily for Stephen, the radio waves are only transmitted by the opaque fog, not by the transparent bubbles.
So that gas outside the bubble produces the radio waves, no radio waves from the bubble. And so for us, we're sort of looking for this Swiss cheese pattern of bubbles and holes in the hydrogen gas distribution.
So although it's not possible to see the first stars, it should be possible with this radio set to find clues about them from the way they cleared the hydrogen fog.
We don't actually see the stars themselves. We see the effect of the star on its environment.
Each atom only emits a tiny signal, but there was a lot of gas, and it all adds up to a signal that Stephen is close to detecting.